we are looking at limits, and there are three techniques. There is brute force. The second method is factor and cancel. And the third main method is called the conjugate method. And basically, that's what we're going to be doing today. We're going to be working on finding limits using these techniques. We're going to do ones that fall nicely into those categories. And then we're going to do some really weird ones, which don't quite fall into these categories directly. They're kind of special cases, and you just have to treat them, individually and figure out a way to solve them. So I'm going to go for this one, which is a version of question 15. And we're going to find the overall limit as t tends to 0 of the square root of 7 plus t, subtract the square root of 7 take away t all over t. Now, normally you would do brute force first, but if you plug t equals 0 in here, you will get 0 over 0, right? And nothing good comes out of that. It's in determinant form. So we are going to do the conjugate method. If I hadn't told you it was going to be the conjugate method, what's the clue in the question that makes you know you're going to do the conjugate method?
The square root.
The square root, right? So you see a square root, it's conjugate, right? And unless it's something like the square root of 2, right? That's not a conjugate, that's just a number, right? And in this case then, it's a little bit uglier than the ones we did yesterday, but it's still a conjugate method. What's the conjugate? That's the name we give to this guy. What goes here?
Square root of 7 plus t plus square root 7 minus t.
Great. Remember, the conjugate is the same square root, guys, but with a plus instead of a negative, right? So I don't care how ugly that is, take away how ugly that is. Won't it just be the same two guys, but with a plus? Now, we are going to multiply all these pieces together. Shows you how much I've been writing. I've actually ran out of ink on my pen. Let me get a replacement pen somewhere.
Wait, is the conjugate 7 minus t, the square root of that, is it supposed to be the plus?
Yeah, my pen is running out of ink, so it's not writing down all the marks that I'm making. So I'm busily trying to find a replacement pen. Wouldn't it be the last class on Friday that I ran out of pen? Okay, I'll use that one. What's the chances this pen's going to be out of ink? You ready for this? Here goes.
I can see the ink in it.
You're right, I can see the ink in it. It's no good. You are getting green. That'll work. Okay, so it is going to be, there the green does work. So it's going to be the limit as t tends to 0. Now, the two guys in the bottom, I am not going to do anything about except write them down again. But these two guys are going to get multiplied together. And this is like a foil from Hades. So I'm going to do it over here. So the square root of 7 plus t multiplied by the square root of 7 plus t, doesn't that just get you 7 plus t? You happy with that? The square root of 7 plus t times itself is just 7 plus t. Now, if you do the O, you are going to get the square root of 7 plus t multiplied by the square root of 7 minus t. And I'm going to make no attempt to make that look pretty. I'm just going to write it down exactly as it is. If you do the inside, of course, don't you get 7 minus t times the square root of 7 plus t, and that's the inside. And if you do the last, you get negative this square root times positive that square root, and that gets you negative 7 take away t. Now watch that last one really carefully. I'll write it down here. If you take this guy and you multiply it by this guy, these two are the same, so 2 square roots make basically the square root go away. Do you see the negative is still there? And do you notice that I put a bracket around it? And wasn't that to make sure that I didn't write that down? Because if I wrote that down, that wouldn't be correct, would it? Because it's a negative of the whole thing. In other words, it's really negative 7 plus t. You see that? Little things like that can really screw up your life. So what I have at the start is a 7 plus t. Now let's look at these two guys in the middle, because the way the conjugate works, don't you tend to get a lot of things killing each other off? These two guys might look sort of similar, but if you really look at it carefully, aren't they the same thing? Isn't it like AB and then BA? So won't this one kill off this one? Gone. And then you're left with this guy, and I'm going to rewrite him now as negative 7 plus t. And oh, the 7s cancel out. So after all that hard work, guess what? You just get 2t. Isn't that magic? Isn't that kind of cool? That horrible guy times this equally horrible guy ends up just being worth 2t. At this point here, don't we just do the cancelling? That t cancels out with that t. And now we can move on and do the limit as t tends to 0 of 2 over the square root of 7 add t plus the square root of 7 take away t. And then what you do at the end is just replace the t's with zeros. So I have 2 on the top. The square root of 7 plus nothing is 7. And the square root of 7 take away nothing is still 7. Okay, can I combine these two together? The square root of 7 plus the square root of 7? Sure.
Yes,
But what do you get?
2 radical 7.
Don't you
Correct.
get the square root of 14?
No, you don't. I know why you would think that. You know, 7 add 7 is 14. But think of it like I have an x plus an x. Don't you get a 2x? I have a something plus the same
right.
something. Right. Easy. I bet you I'll make that mistake sometime. Now, would you agree that we can cancel the 2's? And so our answer becomes even nicer. Is there anything I can do to that to make it even nicer? What I call style points. Because we don't really like square roots on the bottom of fractions, right? Sometimes you can't.
rationalize the denominator.
That guy? Is that what you want, Vanessa?
Yeah.
And you're right. And that is us. Are we cool with this ugly conjugate method, right? It was a messy one. The algebra was got to be careful. A lot of wee places to, you know, run aground. And sometimes one of the worst things about WebAssign is, doesn't it just tell you you're wrong? And you might be 99% right, and you just made one little mistake at the end, and that's why you didn't get the right answer. And then you throw your hands in the air and you say, I don't know how to do conjugate method. I don't know how to do any of these. I'm never getting them right. When really you're 90% right, and it's just one little piece that's bugging you. If WebAssign was really nice to people, wouldn't it say something like, instead of a big red X, hey, you're 90% right, but maybe you would want to look at this bit here, because that bit was where you went wrong. And then you could maybe look at it and say, oh yeah, I forgot that root 7 plus root 7 or root 7 times root 7, whatever it was you did. I did it the wrong way. Oh, okay, I can fix it. What you're going to get in WebAssign is just an X, whether you're miles wrong or 90% right. Are we good with that one? Right. So I'm not going to do it, but if I gave you a conjugate method, would you feel comfortable about the process and off you go and get the answer? Right. So now we're going to look at special cases. I can't think of anything else to call them except that, because they don't really fall into any specific category. I'm just trying to find one now, because there are a few around. Why can't I find it? There's one that I saw a minute ago in the homework that I thought, oh, that'd be a good one to do. Here we go. This one is like question 14. So it's going to be the limit as x tends to 8, 1 over x times 1 over 8 times x take away 8. Now, right now, it isn't any of these three. If I try brute force, you get 0 over 0 in determinant form. It was never, ever going to be a conjugate method. Do you agree? There's no square roots there. You're never going to get square roots there. Don't even think of that as a choice. So I kind of, by a process of elimination, the only one that's left is factor and cancel. But when you look at that, would you agree you can't really factor or cancel anything because it's not really in that format? So now we have to figure out how we're going to make this look pretty. Style points. And I am going to look at this guy and I'm going to say to myself, well, that 1 over x and that 1 over 8 is what the problem is, right? I don't like fractions in any expression, but definitely I don't like it if the expression is already a fraction, right? Which almost all the ones you do are. So I have to figure a way of style points, making it pretty. And a very common technique is multiplying by a special version of 1. Now, if the only thing that was causing me trouble was the 1 over x, couldn't I fix that by multiplying by the special version of 1, x over x? When I get rid of that fraction, x on the top over x on the bottom. If the only guy that was causing me trouble was the 1/8, couldn't I get rid of the 1/8 by multiplying by a different special version of 1, 8 over 8? See how that takes care of that? But I want to get rid of both of them. So what special version of 1 gets rid of both of them?
Is it x minus 8?
Minus 8, or do you want to change it a little bit? It's almost right, but not quite.
8x.
Okay, I think that's what I heard. 8x. Does that make sense? Now, everything here gets multiplied by 8x. Let's see what that ends up looking like. On the bottom, I'm not going to do anything except write it like that. I know it looks ugly, but it's not going to stay like that forever. If you multiply 1 over x by 8x, let's do it down here. If you multiply 1 over x times 8x, doesn't that simplify very nicely? What would 1 over 8x times 8x? If you want to write it as 8x over x, maybe that'll help. What does that become?
8.
8. So that guy's 8. Now, if you want to do negative 1 over 8 times 8x, so put it here, negative 1 over 8 times 8x, right? That's us doing that times that. If it helps, you can call it that guy. Let's put the right guy in the bottom, that guy. What does negative 8x over x simplify down to?
Negative x.
Agreed? So there is the original question. Do you see I've now changed it? And so there's no more fractions. and it did happen yesterday. I recollect it happened yesterday. Aren't you allowed to cancel these two? But when you cancel them, what gets left behind? It's not just a 1, is it?
It's a -1.
It's a -1. So that means we can now do essentially not factor and cancel. We could just do the cancel part because the factoring has kind of happened accidentally. And so it's -1 over 8x. And we can then replace the x with 8. And lo and behold, we got a limit, -1/64. I'll put that in a bubble, by the way. Kind of sneaky, kind of good. Now, when you,
Oh,
yes,
sorry. I have one quick question. So
yes, John,
at the very beginning of your problem where you have 8x over 8x,
yes,
where are you pulling the 8 from? Is it from like the denominators or is it from
Yes.
the limit?
it's from these two.
Okay.
I
So
don't care what that is right now. It's only from these two.
only from those two. Okay,
Yes.
got it. Thank you.
And so when we get a problem like that, do we just multiply the denominators of the fractions that are on the top?
Yes,
Okay.
I love questions where I just say yes, because it means you know what you're doing. You just want confirmation that that's what you're doing. So if you didn't catch what she says just use these two guys, right? I'm not doing this question, but just give you an example. I won't even put in all the details because that's not important. But if you had 1 over x plus 1 over 7 and some other stuff, right? Wouldn't you multiply the top and bottom by 7x? That's essentially what she would say. I'm putting words in your mouth, Rena, but is that kind of what you were asking or saying?
Yeah, that's what I was asking.
Yeah, you're bang right. Yes, you were right to what you just said. We good? Right, let's show you another weird and wonderful one. And this one is similar to question 17. So it's going to be the limit as h tends to 0 of x plus h cubed, take away an x cubed all over an h. Don't need to tell me the details, but what would you do with this x plus h cubed? Because it is not really, the way it's written right now is no good to us, right? We can't do anything with that. Agreed? Just ain't helping. What would you do with x plus h cubed?
Expand it.
Yeah. Now, normally, most questions, don't you just get squares, right? X plus h squared, x plus 1 squared. So let me show you how you do x plus h cubed, because that's a type of expansion that you're not as common. It essentially means x plus h times x plus h times x plus h. And I am not going to do some weird and wonderful expanded version of FOIL, because if I did, I'd screw up. What I'm going to do is just break it into manageable chunks. Don't we all know how to multiply two guys together using FOIL? So what I'm going to do is I'm just going to call it x plus h and only worry about these two guys. You're going to have to trust me because I want to kind of do this quickly, but can you imagine that eventually you'd multiply them and collect like terms? Can you just trust me that that's what you would get when you do x plus h times x plus h, right? You can tie it in your own later, but for speed, I'm just going to tell you that. Now we're left with this guy. I'm not going to call it FOIL because it isn't, although it will look very similar. If you want to multiply a term that's got 2 bits with another term that's got 3 bits, you have to have a very systematic way of doing it or else you'll miss an answer. So here's my systematic way. Take x and multiply it by x squared, and the answer is x cubed. Take x and then multiply it by the middle term. And if you do that, you get 2x squared h and then take x and multiply it by the third and final term. And when you do that, you get xh squared. Are we comfortable so far? What I just did. What do you think I'm going to do next?
Do with H.
Right. So I'm going to take h and go that way. And h times x squared is, I'm going to show you room, so I'll just write it down here. Hx squared. And then I'll do it times the middle guy. And h times 2xh gets me 2xh squared. And then I'm going to do it to the last guy. And that gets me h cubed. You still with me, guys? Do you notice that there are 6 terms there? It's a good idea to just do a quick head count, right? 1, 2, 3, 4, 5, 6. If you do a thing that's got 2 bits and you multiply it by another thing that's got 3 bits, doesn't it make sense that you should have 2 times 3, 6 pieces in your answer? If you had a 2-bit multiplied by a 4-bit, right? So imagine it was an x plus h and some other stuff. Wouldn't you end up with 8 terms? So when you're finished, do a quick head count. Do I have 6? Yeah, good sign. I haven't missed any. Or in this case here, do I have 8? If you only have 7, you've missed somebody, right? Go figuring it out. Would you agree that having a systematic approach like this just helps you not miss one of them? Right. So it doesn't need to be that particular way. That's how my brain works. You might choose a slightly different systematic way. What I should do now is collect like terms, and more by luck than design here, they kind of lined up. Can you see those 2 guys are essentially the same 2 guys, aren't they? Isn't a 2x squared h and an hx squared just another way of saying h squared x squared h? So what you get is 3 of these guys. And aren't these guys also like terms? And you got an x of this and 2x of that, so you're going to get 3 of those guys. And then you've got that guy. So we can now return here, switching places. And this guy is all of this. So we have an x cubed, we have a 3x squared h, we have 3x h squared, and we have an h cubed, and then we take away an x cubed. And that guy gets killed off by that guy. We're slowly and surely getting closer and closer to the answer. This situation has happened before. What do I do to the top line, the numerator?
Factor out an H.
Say it again.
Factor out an H.
Agreed. Can you remember doing that? I can't remember what question it was, but wasn't there a question, at least one, where we had to do that as well? Essentially, haven't I now done factor and cancel? This is where we are. Now, we factored out an h. We can now cancel the same h that we factored out. And now we're going to have the limit as h tends to 0 of this. And you might be a little bit worried that there are x's floating about. Nothing wrong with x's. Not all answers to limits are numbers. You know, x squared can be an answer sometimes, right? Or 4x or whatever.
I think you factored out an H squared instead of just an H on the middle term.
Oh, thank you. Yeah, well caught. Now, don't we just plug in h is 0 and see what pops out? So 3x squared plus 3x times 0 plus 0 squared And that's nothing, and that's nothing. So guess what? There's your answer. 3x squared. Are we good with that question? Are we comfortable with what happened here? So we've seen quite over the last 2 days, we've seen quite a lot of different situations on how to find limits as x tends to 4 or h tends to 0. We've done brute force, factor and cancel, we've done conjugate, and mostly today, haven't we been doing special cases where you have to do a bit of algebra, you know, to make things work? And that's pretty much all the situations that you need to worry about right now. So I'm now going to return to the beginning of the homework questions. So if any of you have looked at the homework, you might say, he didn't go over questions 1 and 2. I wonder why. That's because I want to do it now. And I chose to not do these at the start because they are a distraction, right? Would you agree what we're doing right now is algebra, and they kind of all the methods work well together. If I'd done what I'm about to show you early, it would have actually put you on the wrong road. Right, are you looking now at question 1 from the homework? Is that what you can see in front of you, guys? Right, I'll make it a little bit bigger because I've got a bit of room and some of you have small monitors. So what you're being asked to do here is a very special kind of question. It's not factor and cancel. It's nothing to do with any kind of algebra. It's to do with evaluating limits because they have certain properties that are kind of nice. If you are told that the limit as x tends to 3 of f of x is 4, and for g of x at that number it's 2, and for h of x it's 0, you can actually find the limit of any combination of f, g's, and h's that you like. So for instance, what would the limit as x tends to 3 of f of x plus 3g of x? Well, I know what f of x is, it's 4. And I know what g of x is, it's -2. So it shouldn't be a surprise that wouldn't 3 times -2 be what you would get if, whoops, that's not 3. Where the heck did that come from? Plus 3 times that guy. In which case, what do you get? You get an answer of -2. Does that make sense? That if you want to find the limit of a combination of these, don't you basically just say one of those guys plus 3 of those guys, and what do you get? Intuitively, that's nice and easy. It's called the limit laws. Basically, the limit laws say, if you know the value of individual functions that say x equals 3 or -3 or any number at all, you can find the limit of f of x plus 4g of x's or any other combination. What do you think you would do for question B then? It's a limit of g of x cubed. What would that be? What number would that be? Or calculation if you want.
So it would be -2 cubed.
Great. So as a calculation, it's that, but all you write down is -8. Oh, that means then, can't you do anything to a limit? And as long as you know what the original limit is, you can get that one. So won't that be just the square root of whatever the limit of f of x is, which is 4? So won't that be the square root of 4?
Maybe the plus minus square root of 4.
We'll assume it's positive because it only has the sign. If it wanted it to be negative, they would have put it in there. So just 2. Well, do that last one. G times h over f. G is -2, h is 0, and f is 4. So that for me would be -2 times 0 all divided by 4, which is actually just 0. If you were doing that question, my apologies. If you were doing that question right at the start, and then we started doing conjugate methods and factor and cancel, What's wrong? Oh. Chloe's decided to bark at a leaf going by. And now Bailey's decided to tell me that Chloe is barking. Okay, while those two settle down. Hey, cut it out. Bailey, come. Here, boy. Come on, boy.